Resume recording. And now share the screen, this one. So I guess you now should be able to see my screen, hear me well, see me well, and I guess we are set. It's dark. Is it still dark? Black screen again. Okay. Share screen, and let's try it like this. I have an app actually, and now it should be better because now I'm sharing the screen, not a window. It tells me that I am screen sharing, so. Advanced sharing options, all participants. Share screen, advanced. What else can I do? My Zoom is up to date. I installed it like 5 minutes ago. Okay, so let's try it like this. I'll move this window to here, and then I'll try. No, I'm not on a Mac. I'm on Linux, and maybe that's the problem of it all. Okay, so can you see it now? Now you cannot see it. It's still black. Well, let's start. Okay, so let's try it like this, maybe. Maybe I can share a piece of my screen instead, and then it will work. Portion of screen, share. That's the portion of screen I'd like to share. How to make it larger though? Yes, is it slide? And I can send you a link, but I just wanted to have something on the recording. I actually restarted Zoom like 5 times before, and it worked, and that's the best part of it. Okay, so let's do it like this. I can share you a link to the presentation that I'm sharing right now, and then you will be able to actually join the presentation and see it by yourself in real time. And I think that actually is going to be the best. Okay, so I'm going to present this one. I want to have this link for you. Here's the link for you to actually see the slides as I'm going to go. This is going to go here. Yes, I want a speaker view in here. And now we should be set with all of it. Okay, I see that Jan joined. At least I can see your camera.
Okay, I'm here just to help you out.
Thank you very much.
Let's see, I need to quickly find where you shared the presentation so I can...
I shared it on a chat, so I guess you should be able to see it.
I just have too many tabs. Okay,
that's a known problem.
Yes. Okay, let me jump to ODS and go here.
And I can also see your screen, so that's great.
So I am going to kill my camera. And I am going to pin my videos so that everybody should be seeing that as their main thing, even if I'm speaking. And I'm going to mute myself, and you can just tell me to, I don't know, is that okay. Like something you manage?
Okay, so let's try. I'm talking right now. Can you see me? Can you see the screen? Just let me know in chat, please.
Yeah, I can see you and hear you.
Okay, and I'm also saying the same. Just when you speak. Okay, so I have to speak all the time. I'm just going to murmuring all the time. So the screen goes away as I speak. Okay, so I just hope somebody will make the best out of it.
Or let me share this. Let me try to share screen here.
Yeah, so I'm
desktop one, and that should.
Okay, so I'm also sharing my screen.
Oh.
So we'll just see how it goes. Turn off your video, like my video.
Right now I am seeing the shared screen, so let's quickly check.
Okay.
Okay, so no, that's my screen that's being shared here.
Okay, so I'll start my video, and can you see the screen all the time right now, even if I'm talking?
Yeah, well, you can keep your video on because now since it's shared, it should be fine.
Okay, so now it should be fine. It's working now. Okay, so that's nice because it's not me actually sharing the screen. No. I need one person to tell me what you should turn off your video. Okay, so I'm stopping my video right now. Is it fine right now?
Oh, no, so it's my video that's doing this. Okay.
You should not speak. Okay, so let's do it like this. Okay, so let's just use the slides. I'll keep my camera on and just let's stick to the slides, and I hope somebody will just montage it later. Okay, I guess that will be the best. Oh, now.
So did that just.
Yeah, so now my Zoom just opened on full screen.
And are you seeing the presentation?
Yep, I am.
Okay, so.
Okay, don't touch anything. I'm not touching anything. My hands are in the air, and I guess we can finally start. So, okay, so here's going to be a cut, I hope, and we'll just forget about it for the next year. Okay, so welcome everyone. I wanted to say great thank you for having me here. I was on the Meteor conference last year, and it was like really great. So I wanted to do it the same this year. But this year, I'm not the person who is actually going to talk about uniforms. We have other people to do that. Thank you. So we are going to take another topic on the board right now. So today I'm going to talk about the many phases of performance in Meteor. And what does it mean? We'll get into it in a minute. So first of all, I was asked to say anything about me, like just anything. So I'm a software architect at Vasco. I guess you already saw the company logo. We are this year's one of the sponsors, so you can also see that. Maybe you also heard about uniforms, the package that we did, or maybe you saw us somewhere. I hope so. Personally, I'm working with Meteor in production for over 6 years right now. So let's say, I think I can say something about Meteor and scaling it. And I also the creator of uniforms. So if you ever saw this package, I guess you saw my face somewhere on the internet. And if you'd like to hear more about me, like read more about me, I have a blog and I do a lot of things in there, mostly connected to IT, but not only. So feel free to jump in and just try to read some random stuff about me. So that's about it. And the motivation for today's presentation is actually one of the forum topics that we had, I think, mid last year, and it was about the performance and scaling of the applications. And they started drilling now. I hope you won't kill me for that. Can you share the back of the file section on the chat? Okay, so I'm not sure. I'm the file section of the tab. Okay, so yeah, sure, I can do it, but I think I have to do it later. Yeah, I wouldn't like to actually get into the presentations right now. Okay, so let's continue. So basically, we spoke about the performance in there, and the point was that I am working also as a Node.js consultant. So when I'm, for example, reviewing the applications, these are not only Meteor apps, but in general, like Node.js applications. Most of them are web applications. And I can tell from my experience that in most cases, Meteor is not the source of performance problems at all. It's always something like outside of Meteor, like somebody's doing some like crazy computation in the background, maybe your database is not optimized, maybe there are other things. So basically the point of this presentation is that we are not going to talk about Meteor as a Meteor, but the Meteor as a Node.js framework and what you can do actually about it. And most importantly, I'd like to focus on what we can actually measure while working on stuff, right? So here are two links in here. One of them is actually the forums post and forums thread where we actually discussed all of those stuff. And on the other hand, we also have like blog at Vasco, and we also write down those things in there. So here's a short blog post about how to measure things, how to analyze the data in a very visible way. So I guess we could start. And the beginning in here is going to be about the example application that we are going to talk about. So in here, we are talking about a Meteor application. And what does a Meteor application has? It has some sort of a front end and some sort of a back end, right? That's obvious. And of course, in our case, we are talking about Meteor. So we have the Meteor wrapper on top of that. So we have the code for the front end and for the back end. And how those two interact? So on one hand, the front end is fetching the bundle from the back end, and that's not only the HTML that we sent with the initial bundle, but that's also the initial JavaScript bundle, right? And this bundle has to be parsed, this bundle has to be evaluated in the browser, and this may take a while if we are talking about like megabytes of JavaScript and maybe some low-end phone or some low-end laptop, right? So this is one important part. And then once we load the application, we have to somehow communicate with the server. And in our case, in Meteor, we are using DDP. So we are using this protocol over WebSockets to communicate both ways. So the clients can, for example, execute methods. The client can, for example, subscribe for data, and the server can provide the results, or at least provide the real-time data that the client subscribes to, right? Other than that, we have to get the data from somewhere. So we have the database in the picture. And how do we actually communicate with the database? Well, the client is not communicating with the database at all. Only the backend does, right? And how does it do it? Let's say in a simplified form, we only have queries. Some queries are getting the data, some queries are mutating the database, so like updating the fields, adding more data, all that stuff, maybe removing some of it. And we also have some background tasks. I call them crons in here because in most cases, those are, let's say, time scheduled tasks, something like the normalization, maybe some synchronization with other services. But I just call them crons for like simplicity's sake. And what else do we have in here? We have some third parties. And these are basically everything you can imagine. This can be sending an email, maybe querying the payment system. Maybe it's your own microservice. Maybe it's, I don't know, Google or Facebook, LinkedIn or whatever, any other third party, right? And in here, you can also be the third party, like you can also be the source of the data. For example, you can expose some APIs for third parties to actually retrieve and to actually fetch. And in here, I'm not going to talk about it that much in detail, but let's say that we have, for example, REST and or GraphQL in here, right? These are the two most, let's say, leading technologies, I would say. And in between of them, we have the network, right? I know, network is also between our backend and the database, but in most cases, we assume that the backend and the database should be within the same data center, so they should be at least on a manageable level of the network delays, right? Those delays between backend and database should be, and hopefully are, much smaller than between, for example, the backend and the front end, so between the backend and our customers' browsers. And the plan of this presentation is to talk about the arrows in here. So I'm going to talk about 7 things on those arrows, how we can actually measure those, what they are, and what does it mean, and actually what we can do to actually improve them. And most importantly, for this whole presentation, we are not going to focus on the code at all. So I'm not going to show you code snippets. I'm not going to talk about certain packages. I'm just going to focus on the ideas, because I wouldn't like this presentation to become outdated after a week or after a month when a new package will come in or a new version of something will pop up, right? So we'd like to have some content that is actually able to stay valid for a year, maybe 2 years, maybe 5 years. So we are not going to focus on the code, we are just focused on the transitions, the ideas, the roles in this architecture, let's say. So let's get to it. So first of all, we have the bundle size. I guess you heard a lot of times that we have to optimize the bundle sizes, right? Because not everyone is in a place where the internet is free, the internet is extremely fast, and the machines are extremely powerful, right? I guess we all have been there. So how to actually measure those? So in Meteor, we are extremely lucky because we have a great tool working out of the box. I hope most of you recognize more or less the same chart in their applications. And this is the bundle visualizer. So that's one of the Meteor core packages that you can actually run with every Meteor application, and you'll see how does your bundle look like. It's not ideal. It's not going to be, let's say, extremely useful if you don't know how to read it. So this will be a separate presentation, I guess, to actually explain how to read them and how to actually make use of it, because sometimes you have to know what can be removed and or delayed and what cannot. But basically the idea in here is that you have an overview of what your bundle consists of, right? And that's the main point of this tool. And how to actually improve on the bundle size. So first of all, you can use dynamic imports. And dynamic imports on their own are not really magically in any way. So they are not actually getting rid of the code that you have. The code is just loaded later. So this is not a solution. This is a way to change the characteristic of the performance of the server. Because once we have a single bundle, it's, let's say, I don't know, 7 megabytes, 5 megabytes or whatever, and we can split it. So the client, while opening the application, will download only a megabyte of it, or I don't know, maybe 2 megabytes. And then the rest can be downloaded later, as late as he needed, right? So it's not a magical solution, but just some way to reduce the initial bundle. Later, what we can do is we can actually use some smaller package alternatives. So for example, I guess you may heard about Preact. This is an alternative for React. But the point is that they are often quite few alternatives that you can actually use, but in most cases, they are not identical in their APIs. So they can have, for example, different characteristics. They can have, for example, different APIs of some sort. Maybe they are not fully featured and they are missing some features that are actually needed for your use case. So in this case, you have to actually make sure that the package is going to solve all of your problems, right? That's the important part. Most obviously, you can remove that code if you have any. And I can assure you that there is any in your application, because if your application is actually being developed for more than half a year, maybe more than a year, there's definitely some dead code that you can get rid of. Sometimes it's only a single, I don't know, prop in your component. Sometimes it's an entire component, but sometimes it's an entire set of views with backend logic and all that stuff. And it can accumulate actually to a lot of removed lines if you focus on it. And finally, we have something that you don't really have to think about. So we have tree shaking. And tree shaking on its own, it's a very simple idea. So the idea in here is that if we have some packages, for example, NPM packages, but also your own code, and we are not using all of it, we are just using parts of it, then we are not going to bundle all of it. We are just going to bundle the parts that we are actually using. But it's not there in Meteor. There's a pull request, it's pending, and I hope it will happen soon, but not ready yet, just yet. Next thing, we have the readiness time. And readiness in here means how soon the browser is ready to render the application. So it's only about the HTML that you download, and it's only about the initial JavaScript bundle that you evaluate. So it's not about downloading the initial data to actually render something for the customer, but at least have the code analyzed on the client side to be able to proceed with it. For example, to request the data from the server. So what we can do in here, we have to measure it somehow. And how we can actually measure it. I hope you know this logo. This is actually the Lighthouse. And the Lighthouse is, I guess, one of the most known tools, and not because it's great. Okay, it is great, but it's not known for it, but it's actually known because it's actually bundled with Chrome. And I think also with Chromium. So if you're using Chrome, there's a performance tab in your DevTools, and you may actually use it to see some meaningful measurements for your application. There are things like first contentful paint, which is basically the time where the user actually sees anything in your application. There's the speed index, which is mostly calculated by the time needed for the network to process all of the data that you want to send to the client side. We have the largest contentful paint. Paint should be in here, not pain. It's not the largest pain, really. This is actually about the most significant piece of change in the UI. So for example, when you are opening the application, first thing we can see, maybe it's a loader, and the loader is just, I don't know, 10% of the screen. And then after the loading finishes, you'll see all of the application, and then you know that, okay, the application is more or less ready, and that's this metric. What we have next is the time to interactive. So this is the time needed by the browser to analyze the bundle and then say, okay, the browser, the website is ready and you can interact with it. And what does it mean to interact with the website? It means that, for example, the buttons are already there and you can click them. Maybe the inputs are already there and you can type in somewhere, right? That's this part. Then we have the total blocking time, which is somehow accumulated all those things above. And then we have the cumulative layout shift. This is quite tricky to understand, but basically the idea is that what we often see in the website, especially on mobile, is that you open the application, you see, okay, here's the link I want to click, and you reach for it, click it, and then the website slightly shifts because something was added. Maybe an ad, maybe a header, maybe the font changed, maybe the image got loaded, maybe, I don't know, something changed, right? And the website just shifted slightly. And this metric tells you that, okay, maybe your website is extremely fast. It's loading almost immediately, but then it's moving around. And people are just getting extremely frustrated that it happened because they just misclicked something and they have to go back and wait for it to load and then click again. And all of the process just continues, right? So these are the metrics that Lighthouse is actually measuring. Those are really evolving with time. So most of these are actually relatively new because I think up to last year or maybe year and a half, Lighthouse actually had a different set of metrics, but then they decided that these ones are most important for the customers. These ones are actually most important for the users because the user doesn't actually care how long it takes for a network request to be finished. But if this network request means that I don't see anything, then this network request is important, right? So these metrics are evolving. You have to make sure that you know that what their meaning is, but there's very, very comprehensive documentation of those. So we can just actually go read through it and understand what's happening in there. And how to improve on all of those. So basically, first of all, reduce the bundle size, because if you are going to reduce the bundle size, so the first thing we talked about, all of them are going to be impacted in a powerful and very, very good way. So for example, if your application is loading for 5 seconds and then it takes 0.1 second for it to be ready, then it's great. But we have to reduce the 5 seconds of loading time, right? So bundle size is the most critical part in here. And then on the other hand, we have a very thorough documentation, also like guidelines for every metric. How does it actually impact the customer, how you can actually improve it, how you can improve it on different levels, because it's not always your application code. Sometimes these are things like content delivery network. Sometimes it actually makes sense to, for example, host the application in different data centers and all that stuff. So there's a lot of things in here. I wouldn't like to go in details because once again, this would be a separate presentation about it, but these guidelines are really great and they're extremely helpful if you are just starting with the topic. If you never saw them, just go read through them. Maybe you'll learn something, even if you're not going to use Lighthouse in the soonest future. Okay, let's move on. So right now we are going to talk about something very Meteor specific. So about Meteor's methods response time. How do we measure it? Well, we can do a lot of things in here, but I'd say let's do only one of them. Let's just use Meteor APM. This is a really great piece of software that Kadira created and invented sometime in the past. I know. Now we have it on either Galaxy Professional plan, or we are just going to go to Southern and pay for Monty APM, or just use a free plan. Free plan is also great with Monty APM. And what we see in here, we can see a lot of very detailed information. So first of all, we can see that, okay, we have a method, and this method took some steps. For example, it fetched some data from the database. It required some computation time. Maybe it waited for other methods because this is like the Meteor way of working with queuing stuff on the server, right? So these are very detailed information. On the other hand, you can also have a lot of charts. And I know I love charts. Charts are great, but these are actually really meaningful charts. We can see things like whether or not our application is bound by the database or by the CPU, or maybe there are some asynchronous operations happening, maybe some external services are lagging and we have to improve on those. right? So we have a lot of information in here. It's extremely condensed because what we do see in here, it's the summary of all of the methods that happened within a single minute. So for example, if your application has like thousands of method calls within a single minute, you'll see all of them in a single metric, in a single chart. But then we can also split the charts, for example, per method, and then see how the method changes with time, right? What's also important in here is that we are actually able to analyze the trend of the change. So let's say you see that one of the methods is extremely slow, and then you want to, for example, optimize it. So you did something, and locally it improved the method by 50%. And you are thinking, okay, that's great, 50% less, that's extremely best, like that's extremely great improvement, right? That's just lovely. But the problem that may be that this improvement is not really good one because we just focused on a method that is extremely cheap for the customer to call. For example, if you are, I don't know, if you're optimizing a method that is taking less than 50 milliseconds and you cut it by half, then you optimize it by 50%. That's right, that's true. But you optimize it in a way that nobody's actually going to notice it. It's going to be great on benchmarks, but it's not going to impact the customer, right? And that's why those really compound and aggregated average statistics and charts are actually great to look at. And how to actually improve on those. So if we're talking about methods, only methods, not applications, not only methods, we can actually say that some of them don't have to wait for others to be finished. So what does it mean is that there are some methods of yours that you know are kind of finished at a certain point, and you can say, okay, other methods can continue, like they don't have to wait for me to finish. And I think the best example in here is that if you are using some external services, I don't know, you are maybe calling some data, like some external database, or you are doing some API calls or sending an email or whatever, this delay may be significant, but it's not going to change anything. Like it's not going to be a big difference if the user will wait for it or not. And you have to know it, like this is part of your business logic. This is not something that you can always apply, right? And then it can be very significant for the customer, because if in certain places they are executing a lot of methods one after the other, then unblocking some of them may actually reduce the total waiting time significantly. But also keep in mind that that means that those will be executed semi in parallel. So that means that those will be actually on the server at the same time. And if those, let's say, external services will return you tens or thousands of hundreds of megabytes, then it may kill your application. Just keep it in mind. Maybe not kill, but maybe degrade the performance of it, right? So just keep that in mind. What we have next is we have the option to reduce the number of operations. And that's a very broad sentence, but basically, if you have a method, like a Meteor method or API method, and you can get rid of one database operation, it's most likely going to be faster. Or if you can, for example, get rid of an API call, it's also most likely going to be faster, right? And are there some general rules how to get rid of them? Well, not really. But if you'd like to talk about some general ideas in here, I would say that most importantly, think whether or not something is optional at a certain point. For example, if you can say that some operation will definitely fail, then just skip it. Or for example, if you know that some operation will definitely succeed and you don't need the data now, you can have it later, then maybe you can skip it, maybe you can delay it, maybe you can, I don't know, do it later in a batch. It's also going to be faster. What we have next is improve the database access times. So if our methods are, for example, executing some database operations, like reading it multiple times, maybe updating it multiple times, it's quite important to make sure that the database operations on their own, like every single one of them, are actually short and are actually fast enough for us. So we're going to go through that on the last part of the presentation. And most obviously, at the end, at the very, very end, just optimize the code itself, right? And what does it mean? Well, just get your code, launch the profiler, and just do something about it, right? There are no rules in here. You just have to know what your application does, and you have to know what to do about it. It's your code. You work on it, not me. What do we have next? So, let me get some light. what do we have next? So we have the publications response times. So again, we can use the Meteor APM in here. These traces are extremely similar because those are also computed of like the waiting time, some computation time, some database operations maybe, and all of those details. But the charts are, I don't know, maybe that's something that could be improved in the APM itself. The charts are slightly less detailed. So on the chart itself, you can see that the response time are, let's say, averaged in here. That's also important because we can see that the average response time just increased or decreased while we did some change. But the most important part in here, I would say, is the subrate and active sub. So we can see, for example, how many publications, like simultaneous publications, we have at the moment. So if we'll say that, okay, our application started lagging, so is it because the publications are getting slower and slower, or is it because we have so many at the same time that our server is actually not able to process all of them, right? It's something that we can actually see in here in a very simple way. And then you can actually see that, okay, maybe we have too many simultaneous publications of this kind, and these are extremely hard for our servers to process. We can optimize on them, we can publish fewer results, maybe we can limit some fields, right? We can actually see all those things on those charts. And how to improve in here? So as I said, we can publish fewer documents. What we can do, other thing, is we can actually extract some shared publications. So this may be quite confusing. So the idea in here is that Meteor has some kind of a multiplexer of the publications. So if multiple users, let's say 10 of them, maybe these are 10 users from the same organization, would like to subscribe to the document of the organization they are in. If they would use the same query on the server, Meteor will actually be able to deduplicate this observer on the database and just have one observer for all 10 of them, right? So what you can actually do, let's say the user, when opening the app, will actually load all of his organizations and then all of the data of his organizations. You can slightly change it in a way that he's going to fetch all of his organizations and then subscribe to the organizations one by one. So in total, we'll have more concurrent subscriptions, but the subscriptions for the organizations may be shared between users, right? So there's like slightly more communication between the client and server, but the server has like significantly fewer database observers. And this is significantly improving the database load, but also the RAM usage and CPU usage. Of course, there's Redis oplog from Cult of Coders. That's a great package. Go ahead, try it. It's extremely simple to set up. And also you can reduce the number of operations, just like we did with the methods a minute ago. Of course, the database access times and the code, right? So these are quite simple and quite similar to the Meteor methods, right? Like in the end, it's the code, right? The difference in here is that those can be impactful because they last for time. And methods are just like one shot, right? You just execute the method, get the results, and you are done. And in here, those are stored in the server while being subscribed. So you have to make sure that you are not just going to store, I don't know, terabytes of data in the memory, right? Let's move on. Now we have the API response times. So how to measure them? So first of all, multi-APM implemented something like an HTTP tab that you can actually go and see the same kind of metrics that we saw in the methods and the publications, but for HTTP requests. For example, your REST API calls, for example, your public files being served if you are not using CDN for that, right? Meteor APM is not there, but as far as I know, it is on the roadmap. If it's not, then Philip, let me know. I hope I'm not lying in here. But also we can use non-Meteor APM. And that's actually the point of this presentation. Meteor is a Node.js framework. And you can actually use all of the toolings that are out there for your technologies and or for Node.js, right? So if you're using GraphQL, you can use Apollo Studio. If you are talking about the Node.js only, You can use the Datadog APM, maybe Elastic APM, New Relic APM, Raygun APM. There's like tens and thousands of them, really. And you can actually maybe pick and match what do you need. Maybe you're using one of them, like, I don't know, maybe you're using Datadog for another purpose. Maybe you're using it for some client-side measurements, and you can actually use the same for the backend. And then maybe you'll be able to correlate those metrics that, I don't know, your client side got slightly delayed. The client side code is actually slightly slower right now. And you can correlate this with, for example, your backend performance, right? APMs are really great tools for doing that. And they don't have to be really Meteor centric. You can just use any Node.js generic one. But also you can use logging. And that's maybe also not so trivial, but basically I know logging has a different meaning. So we want to log some stuff. Maybe log an information that something happened, maybe have some warnings, maybe have some errors and all that stuff. But basically the idea in here is that you can use your logging service to log the information about your API timings, and then probably have charts made out of them. So that's basically the idea in here. And once again, there are thousands of logging services that you can actually use. And how to improve on them? So the question in here is how we can actually improve the API response times. I don't know, maybe it's a GraphQL API response time, maybe there's like a REST API response time and all that stuff. So I would say that you can do everything, like literally everything. If you're going to improve the code, it's going to be better. If you're going to improve the database, it's going to be better. If you're going to improve the routing, it's going to be better. If you're going to implement load balancer, basically everything, it is going to be better. Maybe not significantly, but it is going to be better. And that's the point, right? We want to have faster API requests. Okay, now we have the cron jobs. And these are kind of tricky because as far as I know, there are not any like cron specific monitoring services and or APMs, but most APMs like provide you with some functionality to actually provide some custom metrics. So you can say that, okay, this is not an API call, this is not a database call, this is not a method call or a publication call, but this is my own kind of trace that I would like you, my APM system, to measure, right? And you can, for example, provide some custom information about it. Maybe the name of the cron job, maybe the time when it started and all that stuff. And other than that, what you can do, and I actually did it quite a few times in the past, and it's actually extremely simple and it actually helps, is you can actually expose your cron jobs via a REST API or GraphQL API or maybe some other kind of API, and then just use your normal APM for doing that, right? Because in the end, cron job, it's just some code that you would like to be run on a periodical basis. Right? So what you can do in here is you can actually get this code, expose it via API, make sure that nobody from the outside is actually able to execute it. Maybe you have to have some extremely complex authorization for it. Maybe you have to be in an internal network to call them. It's up to you. And then you have your normal APM tooling to actually measure the cron jobs performance. And how to improve them? Well, just improve the code of it, because it's just like code like any other, right? This is the same as for methods or API calls. You can also perform them less frequently. And that may sound very silly because, hey, I'm just doing them as soon as they are needed. Yeah, true. But maybe, just maybe, it's the case that you can actually split your heavy cron job into multiple ones. And then one of them will always be called as soon as you need it, or as often as it is right now, but the part of it may be called less frequently, maybe twice, maybe 3 times, maybe 10 times less frequently than the one that you have right now, right? And another idea that is quite popular, let's say recently, because Node.js finally implemented some kind of a worker system, you can use some worker nodes. So on one hand, you can use the workers that are built in the Node.js right now, just to do some, let's say, offsite CPU work, when you can have like entire microservices only for doing that, only for, I don't know, the normalizing data, maybe for doing some external API calls, for doing backups, synchronization with other services, all that stuff. This can be done by an external microservice. And most importantly, and this might be surprising for some of you, you can just use a single MongoDB query sometimes. So back in the day, this is a story time, let's say. So we had some application and we had quite severe problem with a cron job. What it did? Well, it basically accumulated the statistics of one of the collections and just stored it in an external collection, not to recalculate it every single time someone needed. But the problem was that we wanted this data to be somehow up to date. Maybe not real time, maybe not like 5 minutes, but let's say once an hour would be ideal. And the problem is as the data grew, this became a problem, like a significant problem. But after MongoDB implemented the merge aggregation phase, we were actually able to replace this, I think, 500 lines of JavaScript code with a single MongoDB aggregation. Okay, I know this aggregation is extremely complex. It took, I think, like 20 hours to be implemented, but the performance of it means, like the performance of it is basically non-existent on the server side, because the server is not doing anything. The server is just executing a single database query, a single database aggregation, and then the database has to take care of all of it. But the point here is that the database can, for example, join other collections and do all of those stuff without getting the data back and forth from the database to the server and then sending it back, right? It can operate within the same memory area. So it's much, much faster, especially if this is like a very, let's say, scattered aggregation. And as we're talking about the databases, let's think about the database in general. So let's say how to measure your database performance. MongoDB edition, of course, because we are talking about Meteor, right? So I have to say there are some tools how to work with MongoDB. There are some CLI tools, there are some UI tools like GUI tools, but most importantly, if you are using MongoDB Atlas, which I extremely recommend, you have really, really powerful tools at the end of your fingertips that you can actually use. There are tens of charts. Most of them will be extremely scary at the beginning because there's like a lot of colors, a lot of charts, a lot of data, really a lot of data. But if you get used to it and you are focused on the most important ones for you, you are actually able to read through it and actually understand what your application is doing. So in here, we have a chart of one of our applications. And as you can see, we're executing a lot of queries every second, right? It's like, I don't know, 300, 400 queries in the peaks every second. But on the other hand, we are using, for example, getmores. So these are the subscriptions from the server. And as you can see in here, we also have quite a few of them. But on the other hand, we have the comments. And these are, for example, the database operations. And these are happening all the time because the servers are just synchronizing between each other, right? The nodes in the MongoDB replica set. So just get used to them. They are extremely helpful. They are, as far as I know, MongoDB Atlas stores the data forever. So if you ever created a MongoDB cluster in there, your data is there for like years, and it's extremely useful. And how to improve on here? So once again, for MongoDB, we have quite a lot of resources on the internet that you can actually check out. But most importantly, check your indexes. And I know a lot of people actually told you to check your indexes. That's obvious. But what's not obvious is to remove the ones that are not longer used. And most importantly, for some people, I know it's hard to know that your index is not used at the moment. But if you're using, for example, MongoDB Atlas, you can go there and you can see that MongoDB Atlas will tell you that this index is probably not going to be used soon, or at least it wasn't used in the last week or so, right? So we can also have those metrics in a semi-automated way. What we can do next is check your RAM usage, because once your database won't fit in the RAM, the performance will drop significantly. What you can do next is to actually prune old, maybe some incorrect data. It may be more beneficial than I think. Like if you are using the live system for making demos to your customers, you may get rid of this data after a while, right? If you have thousands of them, it may be a significant chunk of your data. And check your queries in a very simple way. Just use explain. So this is going to tell you what does your query does exactly, like in detail, which operations, what kind of data, what kind of statistics, what is the execution plan. It will tell you what the database is doing almost exactly. Okay, so I'm rambling for half an hour right now. And let's focus on what is the takeaway of this reservation. Of this presentation. So there's only one, like really, there's a single takeaway. Just remember it. Meteor applications are Node.js applications, and they are web applications. And you have to remember, like you have to remember about it. You have to treat them like Node.js web applications, and you have to make use all of the content that is out there, because there's like a lot. Like there are tons of articles, blog posts, videos from the conferences. Maybe some people are just having like separate YouTube channels only on improving the Node.js performance. Really, there's like a ton of articles. And Meteor is a Node.js application. Like your Meteor application is a Node.js application, and you can leverage all of them, really. There's also a grain of salt. Yeah, I know, I had to. And this is a citation, like a quotation from me. So people do care whether the software that you use is fast. That's a fact. That's true. We have to agree that the users care about performance, but they don't care about the exact numbers. Like it doesn't really matter whether your application took, I don't know, less than a second or slightly more than a second to load. But if the difference is 1 second versus 2 seconds, well, everyone is going to notice it. You are going to notice it. Your testers are going to notice it. Everyone will see that the application is significantly slower. If you want to read all of it, come ahead. I invite you. Text is there. And that's basically it. So thank you very much. I have no idea how much time do we have left. So it would be nice if we have at least a couple minutes for the Q&A session. And thank you.
Thank you very much. We have about 10 minutes for questions, so write them in a chat, and I will be happy to relay them. And once again, thank you very much for this great presentation and for being a sponsor of Meteor Impact.
And thank you for having us, really.
It's our pleasure. All right, so as always, this takes a while for everybody to write in their questions, and there's also multiple places. You can either use the polls with questions to the speakers.
Yeah, so maybe chat. I'll just light my light in here. Just give me a second.
Sure. Okay.
Everyone is saying thank you, but nobody is asking questions. Please do have some. Really,
give it some time. It usually takes a while to write it out. And
yeah.
Since I am in a full screen mode, I don't see the other settings, which is strange.
Okay, there's one question about this unblock, whether it's the best strategies, put it everywhere and remove where it's not needed, or the other way around. So it's a hard one because it really depends on what your server is doing. I can say that I'm kind of skeptical when to use it. Like I wouldn't definitely recommend to use it by default everywhere. Don't do that, really, because you may be surprised how many Meteor methods you have at once on your server. But what you can do is actually go to the APM and see how big is your wait time. So how long does it take for a single method to actually start executing? So let's say that your method response time is a second. And then if you have to wait another second just to start because other methods are just in the queue, then yeah, just think about which ones should be unblocked. But if your methods are taking, I don't know, a second and the wait time is less than 0.1 second, then it's not really useful to unblock them, right? So it's always best to measure it and see whether it does an impact. In most cases, I have to say that it's not really making a big difference if your methods are fast. But if you are just calling some external APIs, as I said, maybe synchronizing with other services, maybe sending an email, all of that stuff, it may be significant to actually unblock those. What is the main difference between Meteor APM and Monty APM? So let's put it like this. There's a presentation from Zodern tomorrow about Meteor App. I guess you can ask him about it, but I can say it like, try it by yourself, like really. Monty APM has a free plan. You can actually go there and just try it out. And I can say that at the very moment, I'm not going to say that it's not going to change soon. I hope it will going to be changed soon. But at the moment, Monty APM has quite interesting features, like, for example, the HTTP metric monitoring, like continuous CPU monitoring, built-in server monitoring and all that stuff. So you can just try it out by yourself. But overall, the basics that I just presented, like the Meteor methods metrics and publication metrics, those are included in both. And these are equally fine. You have the same data, you have the same charts, you have the same traces, right? Yeah. Okay, so Felipe just agreed with me. So yeah, Monty APM has better features at the moment. But yeah, Monty has API monitoring. So no, it doesn't have API monitoring, but it has HTTP monitoring. So if you are implementing a REST API, then it is a REST API monitoring for you, because you are going to see the same traces like with Meteor methods, but you are going to see those traces for HTTP requests. So for REST APIs, it's going to be actually a proper API monitoring. But if you are going to have, for example, a GraphQL API, and a GraphQL by design is always using a single endpoint, like HTTP-wise, then all of your GraphQL requests are going to be combined in a single metric. So they may not be as insightful as for REST APIs. Meteor APM does not have REST API monitoring. No, it doesn't have it at the moment. And thank you for the question. Great cup. It's a big cup.
Okay, we have some very nice typos. Great cup.
Okay, and there are no questions in the polls section.
Let's double check.
So I guess that's it.
Fine.
We should have more details going in our general opinions, like. Okay, maybe I'll just send you an email, because I'm on too many Slacks at the moment and I wouldn't like to join another one. But yeah, maybe I'll just let you know and I'll just contact you after the presentation.
I have a question. Will you join us for the next Hangout session?
And when it's going to happen?
Let me check there. If I remember correctly, there is in 1 hour. It should be. Let me double check that. So,
yeah, then definitely, I'm up to it.
So right now, many phases of performance. Oops, it just jumped on me. Many phases of performance in Meteor. Next, we have Meteor Man and HTTP client baby GUI. And then we have just my little showcase. Actually, no, it's going to be further than that. So on our time, it's actually at 10 p.m. So never mind. That's probably too late. We have.
We'll see. I'm not going to be asleep at this time, so we'll see.
So it will be just a chill session as always, which means all topics are permissive. So if you have topics around this that you want to go through, for example, you don't want it to be recorded in this session. That's so the chill sessions are not recorded, so you can go in there and have a talk. So
okay, and I also see that Filipa is writing about the performance. Yeah, so I'll just get in touch with you and we can discuss it slightly more. The fibrous replacement, yes, I'm up to date with this topic, and the MongoDB, like asynchronous MongoDB driver. Yeah, so small plugin. If you are interested in how Meteor will evolve with time, go ahead and try to read through our conversation on the asynchronous MongoDB API for Meteor, because it's going to happen soon, I hope. And sooner or later, you are going to be forced to use it. So you can already get accommodated with it.
Yeah, so, for those of you who kind of want to just be only one step ahead instead of like the 2 or 3 steps that, you two are Radosław and Felipe are talking about, always check out the next release PR from Meteor. It's always available. So there it's usually more finalized as well. But if you have the capacity to check out some of the other PRs important like this one, that's much appreciated because feedback is always needed. All right, and with that we are out of time. So once again, thank you very much for everything, and hopefully I'll see you later.
Yeah, and thank you very much for having me, and thank you very much for all the questions. Really, these were great. Okay, and I try to be like in 4 hours on the chill session so we can actually have another talk if you are up to it. So yeah, thank you, and talk to you later.
Bye.